Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper trending on X, published on October 22, 2025, about 2 days ago. The big idea is a mixture of experts for dynamic Gaussian splatting that uses a volume-aware pixel router to blend specialized models, delivering state-of-the-art average results and robust reconstructions across diverse scenes. The paper is titled MoE-GS, Mixture of Experts for Dynamic Gaussian Splatting, and as we'll see later, the implications for both quality and speed are quite significant. Beyond accuracy gains like mid-34 dB on the N3V dataset and 33.3 dB on Technicolor, the study shows pruning can boost speed from about 44 to about 101 frames per second, and distillation enables near MoE quality with a single expert. Alright, the previous segment introduced the motivation and headline gains. Figure 1 shows why a single dynamic Gaussian method falls short, with 3 panels comparing experts. The left panel reports scene-level variations, where different models top different scenes. The middle panel presents spatial inconsistencies across patches within one scene, which means strengths shift region by region. The right panel highlights temporal fluctuations across frames, so the best method changes over time and adaptive selection becomes necessary. So Figure 2 presents the full pipeline. Stage 1 shows independent expert training, where each dynamic Gaussian model learns its own scene representation so diversity emerges. Stage 2 adds the volume-aware pixel router, which takes expert images and produces adaptive gating weights to blend them per pixel across space and time. The right panel lists candidate expert families, including hex-plane embedding, per Gaussian embedding, interpolation, and polynomial strategies. Alright, Figure 3 compares routing designs after the pipeline overview. The top left pixel router assigns weights from pixel features only, which lacks volumetric cues and struggles with view and time changes. The bottom left volume router attaches weights to each Gaussian in 3 dimensions, but optimization becomes unstable because pixel impacts are indirect. The right panels present the volume-aware pixel router, which rasterizes per Gaussian weights into pixels and applies softmax gating. This combination preserves 3D context and delivers adaptive per pixel blending. Well, the previous figure validated the router design, and Table 1 reports results on the N3V dataset across multiple scenes. The table shows that the mixture of experts rows consistently secure best or second best PSNR per scene and the highest average score, outperforming single experts like STG and X4DGS. Performance improves as the number of experts rises from 2 to 3 or 4, though gains taper slightly. This pattern supports the claim of robust, scene general performance. So the previous table showed strong averages across scenes. Figure 4 presents qualitative results on the N3V dataset, comparing ground truth, the mixture of experts image, and 4 single experts. The zoomed patches along the right side highlight windows, hands, and spinach leaves, where the mixture of experts preserves sharp edges and texture while reducing motion blur and ringing. The blue highlighted boxes indicate the most accurate baseline per region, and the combined image still looks cleaner and more consistent overall. Okay, the previous figure highlighted visual quality gains. Table 3 summarizes efficiency with 2 experts on the N3V dataset. MoE-GS with 2 experts reaches about 32.8 dB at 44 frames per second, and gate-aware pruning lifts speed to about 83 frames with 55% pruning and about 101 frames with 75%, while PSNR drops only slightly. Memory also shrinks dramatically, from roughly 879 megabytes to 351 and then 281. Single experts have lower PSNR, but higher raw speed individually. Alright, 2 takeaways stand out. Adaptive blending with the volume-aware pixel router reliably outperforms any single dynamic Gaussian method, and efficiency tricks plus distillation make those gains practical, even close to real time. The broader implication is clear. Dynamic 3D capture benefits from expert ensembles that remain deployable. That is it for the AI Research Roundup. I am Alex. Thanks for listening.